The National Electrical Code, or NEC, does not provide specific guidance on the frequency with which the chemicals in an electrolytic grounding electrode should be checked and replenished. Instead, the frequency of these checks and subsequent replenishment, if necessary, is governed by two primary factors: the manufacturer's recommendations and the user's operational experience. The manufacturer of the electrolytic grounding electrode will typically provide guidelines outlining how often the chemical electrolyte within the electrode should be assessed. These recommendations are generally based on laboratory testing and simulations designed to predict the long-term performance of the electrode under typical operating conditions. The manufacturer's recommendations should be considered a baseline or a starting point for establishing a maintenance schedule. However, it is crucial to recognize that real-world conditions can significantly deviate from the idealized scenarios used in manufacturer testing. Therefore, the second and equally important factor is the user's operational experience with the specific installation. This involves carefully monitoring the performance of the grounding electrode over time and adjusting the maintenance schedule as needed. Several factors can influence the rate at which the electrolyte is depleted or becomes less effective. These factors include the soil composition, the moisture content of the soil, the temperature of the soil, and the frequency and magnitude of electrical surges or fault currents that the grounding electrode is subjected to. For example, in areas with highly corrosive soils, the electrolyte may be depleted more rapidly than in areas with neutral or alkaline soils. Similarly, in areas with frequent lightning strikes or power grid disturbances, the grounding electrode may experience more frequent surges, leading to accelerated depletion of the electrolyte. To effectively monitor the performance of the grounding electrode, it is recommended to establish a regular testing schedule. This testing should include measuring the grounding resistance of the electrode. A significant increase in grounding resistance over time may indicate that the electrolyte is depleted or that the electrode is otherwise compromised. Additionally, visual inspection of the electrode may reveal signs of corrosion or damage that could affect its performance. If testing or inspection reveals that the electrolyte is depleted or that the grounding resistance is increasing, the electrolyte should be replenished in accordance with the manufacturer's instructions. It is important to use the correct type and concentration of electrolyte specified by the manufacturer to ensure optimal performance and prevent damage to the electrode. In some cases, it may be necessary to replace the entire grounding electrode if it is severely corroded or damaged. Good record keeping is essential for effective maintenance of electrolytic grounding electrodes. A log should be maintained documenting the date of installation, the type of electrolyte used, the dates of all inspections and tests, the results of those tests, and any maintenance or repairs performed. This log will provide valuable information for tracking the performance of the electrode over time and for identifying any trends or patterns that may indicate the need for more frequent maintenance. In addition to the manufacturer's recommendations and the user's operational experience, there may be local regulations or industry standards that dictate the frequency of inspections and maintenance for grounding electrodes. It is important to be aware of and comply with all applicable requirements. In summary, while the NEC does not provide a specific schedule for checking and replenishing the chemicals in electrolytic grounding electrodes, the following guidelines should be followed. Firstly, consult the manufacturer's recommendations for the electrode. Secondly, monitor the grounding resistance regularly. Thirdly, visually inspect the electrode for corrosion or damage. Fourthly, keep detailed records of inspections, tests, and maintenance. And fifthly, comply with all applicable local regulations and industry standards. By following these guidelines, it is possible to ensure that electrolytic grounding electrodes remain effective and provide reliable protection against electrical hazards.